Good evening, sir.
Good evening. Okay, I have told you to read the IS codes, page number 1 and 2. That means 13 and 14. Did you do that? Who have done this work? Please tell me. Shovik Mondol.
Yes, sir.
Did you read the IS code?
Okay.
Did you read the IS code? IS 456. I have told you in the class, in the previous class. I have told you, all of you.
Sir, previous class.
Yes, sir. Yes, sir.
Okay. So you was not present in this class?
হ্যাঁ স্যার পেরেন্টস অ্যাবসেন্ট ছিল
Okay. Raka Das. Hello, Raka.
Yes, sir.
Did you read this IS code?
No, sir.
Why? I have told you to read only 2 pages, 13 and 14. Only 2 page. Akash Sen. Akash Sen. I think Akash don't have mic. Okay, Rupam Mitra. Rupam Mitra. সৌরভ রায়।
হ্যাঁ স্যার ওই মোটামুটি একটু স্যার পড়েছি স্যার ওই উপর দিয়ে
ওকে হ্যালো
Yes, sir.
ওকে সো সৌরভ রায়
ইয়েস স্যার
so did you read this IS code?
হ্যাঁ স্যার উপর দিয়ে একবার স্যার দেখে গেছি দুটো পেজ
Okay, so tell me the some example of mineral admixture.
স্যার অ্যাডমিক্সচার
Mineral admixture. According to IS code, there is some example of mineral admixture.
স্যার ওই দুখানা স্যার মনে আছে স্যার একটা ছিল ওই রাইস হাস্ক ছিল আর একটা সিলিকা ফিউম ছিল
Okay,
এই দুটোই মনে আছে
okay. Pujan Sikdar. Hello, Pujan Sikdar. Okay, Mowli. Hello. Mowli Chakraborty. Hello. Rani Mahanto. Hello. Rani Mahanto. Ankush Pal. Ankush.
Yes sir, বলুন।
Okay, did you read this IS code? Page 13 and 14.
No sir,
I have told you na
কোথায়?
last class.
স্যার আপনি কি শেয়ার করেছিলেন গুগল ক্লাসরুমে?
Yes.
ও সরি স্যার, আমি দেখিনি, এতগুলো আছে, সারাদিন অ্যাসাইনমেন্ট আছে, সরি স্যার দেখিনি।
Okay. Himanshu.
Yes sir.
Did you read this IS
Did you
code?
read this IS code?
না স্যার।
Why?
ভুলে গেছিলাম।
Very good. Ronit
Ronit. Yes, sir.
Okay. So did you read this IS code?
No, sir. Time পাইনি একদম।
Okay. Anupama Talukdar. Anupama,
না স্যার,
did you read?
না স্যার পড়িনি,
Why?
দেখিনি স্যার, পড়ে নেবো, চেক
Maximum.
করো আপনি।
No, you have to read this. Okay. Bhaskar Mondal,
Yes sir.
did you read this? Page number 1 and 2.
স্যার দেখেছিলাম একবার।
Okay. So tell me what should be the pH value of water that you are going to use in your construction?
স্যার 6.5
6.8 to 7.
According to
Four.
IS code, is there any this value 6.8 to 7 point like that? What should be the actual value according to IS code 456?
স্যার
6.5 to 8.5.
6 point. Hello.
Sorry sir, I was wrong. সত্যজিৎ বল।
Bhaskar.
হ্যাঁ স্যার বলছিলাম 6 to above।
6 to above. No. Vivek Roy. Saurabh Bepari.
Yes, sir.
What should be the pH value of water?
pH value of water.
According to IS 456.
Sir, 5 to 7.
5 to 7. According to 456, it is not 5 to
less
7.
than 6 less than 6
Less than 6.
Less than 6, sir. Less than 6.
less than 6
Okay. You can see. Is it
স্যার
clear to
greater
you?
than 6 হবে।
I think you can see you can see
Yes,
my
sir.
screen. Can you see my
Yes, sir.
screen?
Yes, sir. Seen it.
Okay, this is the clause
Yes, sir.
5.4.2.
Sea water. Yes, sir.
The pH value of water shall not be
Yes, sir.
less than 6. Okay.
6. Yes, sir. 6.
Shall
Less
be
than 6.
not less than 6. So 6 and it can be greater than 6. Okay. Who said that? 6 and greater than 6. One student said that.
স্যার me
Bhaskar, yes, you said that. So 6 or greater than 6. But it is not like 8, 9, not like that. Okay.
স্যার
So next you have to read the next page, that means page number 15 and page number 16. Okay. page number and
Okay, sir.
15 and 16. There is lot of information. Okay, so you plus
Okay,
remember the table 1, the value of permissible limit of organic, inorganic, okay, and sulfate, chloride, like that, and there is lot of information. Okay, the flexural value, Young's module elasticity value E 5000 over xck, this is important value. Coefficient, tip coefficient is also important. Okay, so all those things you have to remember. Okay, now let me start. The last class I have told you about the doubly reinforced beam section, and this is also in working stress method. Now I shall stop here about the working stress method, and I shall start the limb state method, because actually you have to do all design of reinforcement or design of structural element with the help of limb state method. Okay, so there is no significance of working stress method, and in semester also you have to do the limb state method. Say number 5 or 3 or 10 numbers will be asked to you about the working stress method. Okay, and maximum question will be based on the limb state method. So I shall start the limb state method, and before that I want to give you some idea about the doubly reinforced beam section of working stress method. Okay, so suppose this is a singly reinforced beam, and this beam can resist this M bending moment. Okay, now how it can resist? Okay, 1 minute. So how it can resist the bending moment? It will create a couple of moment. That means this force will create in tension zone due to the tension reinforcement, and this force will create at the compression zone C, and this is T. Okay, and this distance we called it lever arm. Okay, so moment equals to, we can say, T multiplied by lever arm, or C multiplied by lever arm. Okay, now suppose the applied load is greater than the previous one, and the bending moment is also higher than the previous one. So suppose this is M1 and which is greater than N. What we can do? We can create a section which will carry the moment M, okay, and suppose this is C and T, and this section will carry the moment only M. Okay, so C is coming from the concrete and T is coming from the steel. Now the additional moment, which is actually M1 minus M, the additional moment is M1 minus M. Additional moment is m1 minus m. Okay, so this moment can resist another section where the tension will create some reinforcement. Suppose this is say T dash, and compression will create due to the application of some compression reinforcement here. So this is C dash. Okay, and it will resist the additional moment m1 minus m. So if I add those two sections, we can get the actual section. So I should apply the another parameter, otherwise it will not clear. This is suppose T1 and this is suppose T2. Okay, and this is C1 and this is
স্যার
yes.
বলছি সৌরভ রয় লেফট করেছে, ও গ্রুপে দিয়েছেন নিয়ে নেটওয়ার্কের জন্য লেফট করেছে ও।
Okay, no issue.
ঠিক আছে, ওকে।
So now the actual tension is T, which is coming from T1 plus T2. Okay, and actual C is coming from C1 plus C2. Okay, and this particular section will resist, this particular section will resist the actual total bending moment, that is m1. You got my point? So this T is generated due to the application of some tension reinforcement T1 for section 1 and some tension reinforcement of application of tension reinforcement T2 of the section 2. Okay, so this is actually total reinforcement. Here we are applying total reinforcement AST. There is no AST1 or AST2 like that, and you can divide it, no issue. You can calculate it, what should be the AST1 for T1 and what should be the AST2 for T2. You can calculate, no issue. But this C is coming from concrete as well as compression steel. So C1 is coming from concrete and C2 is coming from steel. Okay, so now if I draw the if I draw the bending stress diagram here, so this is the topmost fiber, and this for suppose this is the balanced section and this is the bending stress diagram. Okay, now this value should be sigma CBC and this value should be sigma ST according to IS 456. Now the compression reinforcement is laying at below the topmost fiber, suppose at this position. So how you can get the value of stress value of steel? You can calculate it from the similar triangle. Okay, so suppose this distance sigma CBC by neutral axis depth, okay, equal to, suppose this is KD. Now we can see, write sigma CBC by KD equals, suppose this distance is, suppose x, and x is actually the stress in compression steel. Okay, so x by this distance from the neutral axis, that is actually nothing but KD minus D dash. And what is D dash? D dash is nothing but the effective cover. This is D dash. Okay, so you can calculate stress of compression reinforcement, and from that you can calculate the amount of reinforcement also, AC you can calculate. Okay, so I shall start some problem based on this W reinforced section, and in working stress method after completing the limit state method. Okay, so I want to start the limit state method, and I pause this working stress method right now. Okay, and you don't think that it will stop here. It will continue after some days. Okay, now
Okay, sir.
what is working stress method? What is working stress method? Working stress method means we are applying some load. We are applying some load on a particular structure. Okay, and the structure is in this lifespan of the structure. What is the lifespan of the structure? What is the lifespan of the structure? Lifespan. What is the lifespan of the structure? What is the life? Generally, what is the lifespan of human being? Generally,
Sir, soul, sir.
50 years, sir.
yes, structure's lifespan of structure is 50 year. Okay, our lifespan is suppose 80 year. Okay, so lifespan of structure is 50 year. Now in this 50 year, structure will be subjected to some external load. Okay, so it may be point load, it may be uniformly distributed load. Okay, it may be varying distributed load, it may be, all those are static load. Okay, all those are static load. It may be dynamic load also. Okay, now in this lifespan, the structural element will be subjected to some load, and due to the application of load, the structure will experience some stress. Okay, and if I consider this is the stress strain curve of concrete, you know that according to IS 456, the material will behave like an elastic material. That means material obeys the Hooke's law. That means the stress strain curve is linear. Okay, and in this parabolic portion, some amount is linear, very small amount is linear portion. So we are considering very small amount of load, and we are just neglecting huge amount of load. This huge amount of load we are just neglecting in work stress method. Okay, so this is one drawback if we consider this huge amount of load, huge amount of stress, I should say, this is stress, this is stress diagram. So if I consider this amount of stress, okay, for the particular load, I can use a small section, and small section means the volume will also small, and small volume means small quantity, and small quantity means it is economical. Okay, so cost will be lower. So this is one drawback in working stress method. And if I could says that you just speuse our concrete grade is M20. Okay, so for M20 grade concrete we have to consider sigma CBC is how much? Sigma CBC we have to consider according to IS 456. Please tell me.
7, sir.
7, yes. So according to IS 456 it is 7. Now so this value is 7 and this value is 20. Okay, now suppose you have designed a structure with the help of working stress method and you can't go beyond the 7. Okay, so if the applied load is greater than the design load, suppose you have designed a beam with X amount of load, okay, and if the load is due to this X amount of load, the stress of the concrete will be maximum or permissible, that is 7. Now I have applied some greater load, suppose X1, which is greater than X. Okay, now obviously the stress will be higher than 7, isn't it? Load is higher than stress will obviously will greater than 7. Suppose it is greater than 7, say Y. Now that means this Y value will lie above this line. Y value will lie above this line because this line is the permissible stress of the concrete according to IS 456, that is 7 for M20 grade concrete. So in this limit Y should be there, but why? Where? What is the actual position of Y? That means I am trying to say that if the load is exceed the design load, what should be the failure condition? Okay, will it greater than 20 or will it less than 20? I don't know, because the concrete M20 grade concrete resist maximum 20 Newton per millimeter square stress. Okay, so M20 grade concrete can resist 20 Newton per millimeter square stress, and if your applied stress is greater than 7, okay, if I draw the scale here, suppose this is 20, this is 0, this is 7. Okay, so your applied stress is greater than 7. Okay, now is it 8 or 9 or 19 or it is 21? I don't know, because in working stress method we don't have such a formula to calculate the stress which is beyond permissible value. You got my point? That means we can't say the actual stress of the concrete, we can't calculate the actual stress of the concrete which exceed the permissible value. Okay, that means we don't know the failure criteria. Okay, so this is another drawback in working stress method. Okay, to overcome this working stress method, there is a another method. This is called ultimate load method. Okay, in this ultimate load method, what we have done, we have actually considered the maximum stress of the material. Okay, maximum stress of the material. So for M20 grade concrete, we are not going to consider the sigma CBC 7. Okay, we are not going to consider the sigma CBC as 7. We have to consider sigma CBC as 20. Okay, that means in this method we can say that we can calculate the actual stress of the material, and we can tally that stress with the maximum level of the particular material, and we can say that the actual failure of the structure. Okay, now there is some drawback. What is the drawback? The drawback is like that when the beam or when the structural element is under the service lifespan, then sometimes some problems is creating, and this problem is like that. Suppose the beam deflected like that. Okay, this is not a failure, this is just some sort of deflection. Suppose this amount of deflection is very negligible. Suppose this is 3 millimeter, okay, or 4 millimeter I should say. So this is 4 millimeter, means very small. You can think about that. The 4 millimeter is very small, but for the structure the 4 millimeter deflection is very important. Why? 4 millimeter deflection means there should be a crack at the bottom position of this structure. Okay, suppose this is a beam, this is the beam section, and at the bottom suppose there is some crack. Okay, and this crack, it is a visible crack. Okay, you can see the crack, and suppose you are laying at night on your bed and you can see over your head, you can see the crack, and automatically you will be under fear that it seems that it will collapse on your head. The beam will collapse on your head. Actually it will not collapse, but you may experience some sort of mine. Okay, so this is one problem. Another problem like that, suppose there is the slab over the building, and the deflection of this slab is suppose significant deflection, and the ponding is creating here. That means the rainwater is stored, some sort of rainwater is stored at the middle position of the slab. Okay, that means you can imagine that if rainwater is stored on the topmost surface of the slab, that means the slab is deflected. Okay, and you can imagine that the condition. So this is another condition. another condition is that, like that, suppose in front, suppose you have a multi-story building, or you have a house nearby the main road. Okay, so this is the main road, highway. Okay, so beside the highway you can feel at night that is very heavy truck is moving on this highway. Okay, and you can experience some sort of vibration. You can experience some sort of vibration when you are staying in this house. Okay, so you can think at that time that maybe the structure will collapse within fraction of second. It will not happen, but this is the psychological factor that you can experience. Okay, or suppose you have a flat, and in this flat beside, suppose this is your flat and this is neighbor's flat. Okay, and in neighbor's flat there should be, there suppose a fire, there is some fire. Okay, now this building, this column or this wall is the common column for both family. Okay, and this face of this column experienced huge amount of temperature, suppose 500 degree centigrade. Okay, now at that time you may think that your building will also collapse, because this column is now damaged due to the fire. Okay, so all those things will happen within 50 years at any time. Okay, within 50 years, that means within the service lifespan 0 to 50 year. In this 50 year all those things will happen. So what we can do, we can, all those problem we cannot eliminate. Okay, please keep in mind, all those problem we cannot eliminate. The vibration will also happen. Okay, or the deflection will be occur. We cannot eliminate all those problem, but we can apply some limitation. We can apply some limitation on the structure, like that. Suppose the crack which you can see on the surface of the element or beam or slab, suppose this crack is like that. This is the beam and this is the crack width. Okay, so this crack width, we can limit this crack width, say 3 millimeter. According to IS 456, it is 3 millimeter. That means we say that if the crack width is below 3 millimeter, then the structure is okay. If the crack width is greater than 3 millimeter, then you have to maintain this crack width. You need some treatment of this structure. Okay, so maximum problem of this structure in the service lifespan will occur due to the strain. Please keep in mind, due to the strain. So in the stress strain curve, this is the y-axis. Okay, this is y-axis and this is the strain and this is the stress. This is the x-axis This is stress, and this is the suppose stress strain curve of concrete. And now the new method is coming. In this new method, we don't bother about the stress, because in ultimate load method previously we have seen that we are considering already the maximum stress. Okay, we are considering the maximum stress already. We are not considering the permissible stress, that is 7 for M20 grade concrete. We are considering the total stress, ultimate stress, that is 20. And now we just neglect the stress, and we are focusing on this parameter. This is strain. Okay, this is the major difference between working stress method and limit state method. In working stress method, we are focusing on stress. There is no any calculation based on strain in working stress method. But in limit state method, all those calculation is based on strain, not stress. Okay, so now we just apply a limitation of strain. Okay, suppose now you see that there is the another curve, downward curve. We just neglect this downward curve and we just make it horizontal. This is called engineering curve. Okay, now this is the actual engineering curve of the concrete, and in this curve we consider a particular amount of strain, and this value of strain for India is 0.0035. Okay, and for USA this value, this particular strain value is 0.005. This is for USA. You don't need this value, I am just saying that. And this is Indian, according to Indian standard. Okay, so we are limiting the value of strain, that is 0.0035. Now we are not applying the limitation or permissible value of on stress. We are applying the limitation value of strain. Okay, so we are limiting the value of strain at 0.0035, and from this consideration the name of this method is coming, that is limit state method. Okay, so limit state means we are limiting the value of strain, that is 0.0035 for concrete, and after that we will see the value of strain for steel also, don't worry. So we are limiting the value based on the strain. That's why it's called limit state method. Okay, now that means if the strain value of the, suppose this is a beam section, and at the topmost fiber will experience the maximum amount of stress, and maximum amount of stress means the maximum amount of strain. Okay, and we can say if the maximum amount of strain is under 0.0035, is below 0.0035, you can say the structure is safe. Okay, and it is exceed 0.0035, you can say the structure will collapse at failure. Okay. Now in working stress method you can see the limitation is based on the stress. If I say the permissible stress will exceed for integrated concrete greater than 7, then I have to consider the structure will fail. Okay, but in limited method you have to say that if the strain value of concrete will exceed 0.0035, then the structure will collapse. Okay. Now one thing I want to tell you, I will take just 5 minutes to complete this class.
Okay, sir.
So now this is our stress strain curve of concrete, and this value is 0.0035, and this is the strain value, because in y direction this is the strain. And in this is in x direction, and in y direction this is stress. You can see there is a particular point in the stress strain curve where the stress value reaches ultimate stress. Okay, and we denote the stress in concrete with FCK. Okay, this is FCK, and in the steel this is FST. Okay, FY. Okay, now this is the value of FCK, and you can see for strain value 0.0035 the stress value is FCK, and also for this point also the strain value for this particular strain value the stress value is also FCK, isn't it? Because from this point to this point, from this point to this point 0.0035, the line is absolutely straight line. This is absolutely straight line. Okay, so for both case and between all those point, between 2 point, the stress value is constant, that is FCK, and this value of strain is actually 0.002. Okay, so below the strain value 0.002 the strain will also less than FCK, and 0.002 to 0.0035 stress value of concrete is constant, that is FCK. Okay, so please keep in mind this phenomena. Now in the next class I shall show you the stress strain curve of steel, and you have to understand the stress strain curve of concrete and steel very carefully. After that you can go for limited method of design. Okay,
Okay.
so let me take the attendance today's.
Sir,
Yes,
tomorrow Wednesday 2 p.m. এ class, ওটা হবে তো?
1 minute. Let me take the attendance. Sorry, there is no member. What happened? No member?
ডাউনলোড হচ্ছে না স্যার